Hello Sharanya. Hello children. Welcome to my online teaching. I know you love astronomy, but in order to understand astronomy, you need to know geometry. So, I have prepared this video to help you learn the basics of geometry. Part 1. This video is part 1 of basic geometry. In this video, we will learn about dimensions, lines, and angles. Children, now I am going to show you a video. Watch it carefully and then tell me, what did you observe? So kids, what did you note in this video? Were you able to note that although the things were looking real, they were not actually real? Why so? Because they could not be lifted with hand and they could not be eaten. They could only be seen. So what you have to learn for now is that things which are real are called 3D or three-dimensional, whereas the things which can be drawn on a sheet of paper or which can be seen on the screen of a TV, mobile, etc. are called 2D or two-dimensional. These two-dimensional things are not real. For example, a dot or a line or a curve or any figure for that matter which you can draw on a sheet of paper is two-dimensional. But why do we call them two-dimensional? Because they have only two possible measurements or dimensions, that is, the length and the breadth. They do not have height, the third dimension. On the other hand, things which can be seen in a region of space or which can be felt as real in the hands, etc., are called three-dimensional. They have three possible measurements or dimensions: the length, the breadth, and the height. When we say region of space, we mean any area around us, whether in the air or on the ground. I hope now you can explain the difference between 2D and 3D. Can you? Well, 2D means two-dimensional and 3D means three-dimensional. Dimension here means measurement for eye. Example, things which can be drawn on a paper or which can be seen on the screen of a TV, computer or mobile are two-dimensional. Can you guess why can we not include a fourth dimension? For example, the weight of an object? Well, the answer is, as I told you in the beginning, that when we talk of 2D or 3D, we are basically talking about the vision of our eye. And the weight of an object is not relevant for vision. In other words, we talk of 2D and 3D while talking of size. And weight is not a measure of size. Now, see the pictures below and tell whether they are 2D or 3D. Can you see the rainbow? And can you see the butterflies? Tell me whether these rainbow and butterflies are 2D or 3D. Well, the answer was present in the question itself. When I said, look at the pictures below, you should have got the hint that a picture can only be drawn on a sheet of paper. Hence, every picture will always be called a 2D, two-dimensional. Now, here is a list. What you have to do is to separate the 2D objects from the 3D objects in this list. Can you tell me what is a square? Well, a square is drawn on a sheet of paper, therefore it is 2D. What about playing cube? Well, playing cube is played with, by keeping it in hands, right? So anything which you can hold in the hands is a three-dimensional object. Chair. Chair again, you can sit upon it. It's a 3D. Line or curve. Well, it is line or curve is drawn on a sheet of paper, so it is 2D. Rod or stick. It can be held in your hands, therefore it is 3D. Sheet of paper. Tell me, sheet of paper, it is 2D or 3D? Well, you can hold it in your hands, so it is 3D. Table, 3D. Ball, 3D. Circle. Well, circle is a shape which is drawn on a sheet of paper, therefore it is 2D. Building. Building is 3D. Triangle. Triangle is a shape drawn on a sheet of paper, therefore it is 2D. Hair. Hair can be held in your hand. It is 3D. Good. Now, you know that dimension means measurement. But why do we need measurements? Well, we need them in order to be able to compare things precisely. Look at these children. Can you tell who is taller? Ramhari or Shashi? Now have a look at the pictures, both the pictures here, and tell me who is taller, Dolly or the girl at serial number 1? Well, in both the questions, you will find it difficult to answer. At best, you can make a guess, intelligent guess. So, how can you compare the height of different people? Perhaps you will make them stand side by side in order of their height, as we saw in the previous pictures. But this method has two shortcomings. One, you will need all of them together at the same time. Second, you can only have a comparative idea of their height. You cannot measure their height individually or precisely. So, how do we measure somebody's height, weight, etc. individually as well as precisely? For that, we must have a standard reference acceptable to all. And this is achieved by defining and accepting the international units of measurement. International units of measurement. The most basic measurements we need in daily life are for measuring time, distance, and weight. Let's see time first. The international community has accepted use of atomic clock to define 1 second of time. On the basis of the said definition of time, the unit of distance has also been arrived at. The international community has accepted the distance traveled by light in vacuum in a defined fraction of a second as 1 meter of distance. It has accepted the weight of a platinum iridium cylindrical mass of fixed size as 1 kg of weight. This model weight is kept at Servoz in France. Let us come back to shapes. The most basic shapes are lines and curves. So what is a line? A straight array of points is called a line. Here it is. And what is a curve? An array of points which is not straight is called a curve. Here it is. How can you measure the distance between two lines? Well, the answer is interesting. The distance between two lines can be measured in two ways, either linearly or angularly. Linear distance is measured in meters, whereas the angular distance is measured in degrees or radians. Example of linear measurement. Here is a line. Here is another line. This is the distance between the two, and suppose it is 1 meter. So the distance, linear distance between these two lines is 1 meter. Now let's come to angular distance. Angular distance is measured in degrees or radians. The angle is generally denoted by the symbol called theta. Note that angle is always measured at the point where the two lines meet. Suppose this is one line and here is the second line. So note the point where the two lines are meeting. This is the point from where we measure the angle. And the angle is denoted by this arc. And the symbol is theta. Now, what is meant by the degree of an angle? When any circle is divided into 360 equal parts, then the separation between any two parts is called as 1 degree. This separation will be the same irrespective of the size of the circle. Right? So here we have a circle. What we will do is, we will divide the circle into 360 parts. Then one part will be known as 1 degree. Here it is. Can you see the lines? These are actually the dividing lines which divide the circle into 360 equal parts. All lines originate from the center of the circle. Now here is a practical. Let us do a practical to understand 1 degree of separation. For that, we will divide a circle into 360 parts. But that is a very big number. You will probably get tired marking 360 parts. So let us divide half a circle in half as many parts. That is, let us divide a semicircle into 180 parts. But even 180 parts is a big number. So let us divide 1/8 of a circle into 360 by 8 parts, which comes out to 45 parts. That, I suppose, is manageable, right? So let us take a thick paper, draw a circle and cut it out. So here is the circle. Now cut the circle in 2 halves. You will get a semicircle, like this. Now cut this semicircle into 2 halves again. What you will get? You will get a quarter circle like a D alphabet. Well, I could only put a few marks due to shortage of time. You please complete this exercise, right? 1, 2, 3, like this. You have to divide this 1/8 of a circle into 45 parts. For that, put 44 marks along the outer of this piece. That is, this is the arc. Here you have to divide this arc into 44 equal marks. And then join each mark with the center like this, a straight line. 1, then second, 2, 3. Like this, you will get 45 parts. Right? To further refine our understanding of the angles, let us discuss the 3 positions in which a line can be placed. I hope you know about horizontal, perpendicular, and slanting lines. Can you tell me what is the position of this red line? What orientation is this called? Well, this is called a perpendicular orientation. This is a perpendicular line. Now, can you tell me what is the position of this green line? Well, the orientation of this green line is slanting. Can you tell me what's the orientation of this blue line? This one? Well, the orientation of this blue line is called horizontal, right? So this is perpendicular, this is slanting, and this is horizontal. Now, to be more precise, a line is horizontal, perpendicular, or slanting with respect to the given frame of reference, such as the lines in your copy, the top of the table, etc. We are showing the frame of reference in blue, right? You have to note that our frame of reference will be blue. Then you have to tell that according to that frame of reference, what will be the orientation of the given line. So here is the frame of reference in blue. Now here is the line. What is the orientation of the red line called? Well, the answer is perpendicular, because red line is perpendicular to the blue line. Now, again, this is the blue line, our reference, frame of reference. Then what is the green line orientation? Well, green line is slanting with respect to the blue line. Again, this is the frame of reference, blue line, and this is another line, magenta color line. So what is the magenta color line orientation? It is horizontal. Now suppose my table or my copy shown in blue color changes its orientation, right? Then you have to identify the horizontal, perpendicular, and slanting lines. Here is my table or my copy. This is the direction of my table or my copy, right? Now I will put a line on this table or on this copy. I have put this magenta line. Tell me, what is the orientation of this magenta line? Answer is horizontal, because this magenta line is horizontal with respect to the blue line or parallel. Again, this is my table or my copy, and this is the line, green one. So what is the orientation of the green line? Well, it is slanting. Again, this is the orientation of my table or my copy. Now tell me, what is the orientation of this red line? This red line is, what is the orientation? Horizontal, perpendicular, or slanting? Well, this red line is perpendicular with respect to the blue line. I hope you have got it. Now, mathematically speaking, the angular separation between two parallel lines, that is the lines which are in same direction, is always 0 degrees. And the angular separation between a horizontal and a vertical line is 90 degrees. And the angular separation between two parallel lines in opposite direction is 180 degrees. You need to remember these very well. The angle between parallel lines is 0, horizontal and vertical line is 90 degrees, and two parallel lines in opposite direction is 180 degrees. Now here is an exercise for you. Can you draw the lines having 0 degree angle between them? Suppose here is one line. So what will be the orientation of the other line if the angle between the two is to be 0 degrees? Well, the answer is like this. Now the angle between them is 0 degrees, right? Next question. Can you draw the lines having 180 degree angle between them? Well, here's the first line. Blue line is the first line and this is the second line. Look, now the angle is 180 degrees like this. Like this, 180 degrees, right? And the angle between this and this is 0 degrees because both of them are in the same direction. But here, red line is in opposite direction to this blue line. Therefore, the angle between parallel lines in opposite direction is 180 degrees, this much, like a semicircle. Now, here is a line. Can you draw a line forming an acute angle? Well, this will be the line. This magenta line, which is a slanting in orientation, forms a acute angle. What is an acute angle? An angle less than 90 degrees is called an acute angle. Now, can you form a straight angle? Well, this is the line, one line. So where will be the another line direction if you have to form a straight angle? Like this. This is a straight angle. Perpendicular lines subscribe straight angle. That is an angle of 90 degrees between them. Now, can you draw two lines with obtuse angle between them? Well, obtuse angle means an angle more than 90 degrees. Like this is an acute angle less than 90 degrees. And obtuse angle will be more than 90 degrees. It means this red line will go to this side, left hand side. So this is one line and this is another line. So this is an obtuse angle, acute angle, 90 degrees angle, 0 degree angle, 180 degree angle. Hope you have got it clearly. Practice it a couple of times in your notebook. Then you will not forget. This is another example of an obtuse angle. This line has been tilted downwards. So this is another example of obtuse angle. So what did you find? That angular separation between a horizontal and a straight line can vary from 0 degrees to 90 degrees. In such cases, the angle is called an acute angle. Two lines separated by an angle of 90 degrees are said to be perpendicular or at right angles to each other, and a right angle is denoted by this green symbol, L-like symbol, or this inverted L. Finally, if the angle between a horizontal and a slanting line is more than 90 degrees, then it is called an obtuse angle. Now here is a quiz for you, right? Go and stand in front of the wall clock in your house and watch the two hands moving. Can you tell me at what time do they make a 0-degree angle? Well, there will be many such positions, some of which will be at 12 o'clock or at 5 past 1 or at 10 past 2, etc., etc. At these times, both the needles will be over each other, they overlap, and therefore the angle between them will be 0 degrees. Next question, the quiz. At what times do the needles make 90-degree angles? Think and answer it. Very easy. I hope you're standing in front of the clock. Well, the answer is the 90-degree angle will be formed at various times in various positions, such as when the time is 3 o'clock or 15 past 6 or 9 o'clock, etc. The next question is, at what time do they make 180-degree angles? Well, the answer is at times such as 6 o'clock or 15 past 9, etc., etc. You can write many more times. Next question. At what times do they make acute angles? Well, the examples could be like the times 1 o'clock, 2 o'clock, etc., etc. You can write other such times and examples in your copy, right? Next question. At what times do they make obtuse angles? Well, the answer is at times such as 4 o'clock, 5 o'clock, 7 o'clock, etc., etc. So children, that's all in this video. Keep observing the angles around you. For example, you can observe the branches of a tree and you will find that some branches are at acute angle, some at right angle, and some at obtuse angle with each other. Right? Goodbye to all of you. Happy learning.